Welcome, welcome, welcome. My name's Blades, and yes, we're exploring. It's number 9, so let's explore. What are we going to do today then? A bit of C++ in the style of Qt, and we're going to start unleashing the client. So let's do that then. Let's explore. New folder. We'll call it client. Why not? We can. And in our client, we can have, let's see, what can we have? Anything? Yeah, a new file. I'll just put main. Why not? Main.cpp. I don't really like that. Yeah, no, I don't like that. We'll call it client, because that's what it's going to be. There it is, our client. Oh yeah, remove. I got my pro a bit mixed up, so I better remove that line. Test server is now in at the bottom. So 42, delete, 43, add. And that just puts our server off command in there, which would help, I guess, if you want to turn it off, that is. Yep, that's got everything I think we need there, so we'll leave that alone. We'll use that as a reference, I think, for what we're going to do here. We're going to start our first application, and I'd like to do it in the style of Qt. So let's just get an application first of all. C++. Command design. That's an application. There's your main. Yeah, that's all we need. Copy. Don't know why I've changed it. What did I change? Nothing. Good. Copy, and on line 5, we're just going to do that then. Why not? Hey. And we have to return something, so return 0. So it's a valid program now. Okay, a brand new start with a client. How are we going to do this then? Let's see, just did it in full, so there we go. Client, new file, forget it, no, new folder, source, in the source we're going to do a Qt type of thing, because in Qt they use QApplication. Now what I'm going to do instead, I'm not allowed to do that. So in source, I'm going to have a new file, and it's going to be client application. So I'm going to do it in their style, but probably not their way, if you know what I mean. Source, new file. It will be client application. Yes, we're doing classes at long last. I'm going to do this as an object-orientated design rather than the C++ bit, which was just introducing people to functions and the different types of variations that we could have in there. So application.cpp. In the client, we will also need a client.pro. Yes, that would be good. New file, a client.pro. So let's spell out all of the different bits and pieces we're going to have in here first, and then I'll write the profile. So under source, we're going to have a new folder. This is going to tell you exactly what we're doing, which is going to be called network. done it wrong again, Anna. There you go. Under source, new folder, network. And in the folder, we're going to have network. .h and new file, network .cpp. So we know what we're getting ourselves into. We're going to write a client, application, and a network sort of thing. Yes, it's going to be interesting, that. Anything else we need now? No, we need a build.bat, don't we? Yeah. So under client, new file, we'll have a build.bat or sh if you're on Linux or somewhere else. But if you are on Linux, right click on it, look at the properties and make sure it's executable under permissions. It does help if it is, because it needs to be. Windows isn't that security, well, it's just not security conscious at all, really, at times. So the build.bat's quite easy to do. Let's do that one first. It's just copy. No, I meant copy, which is why I always have that first line blank. And that's going to here. And it's not explore C++, it's explore client. That's the only difference. For future use, I will put that in, because we can now. So that's our build.bat out of the way with. Get that lot, go away. And all we need now, an untitled. Where's that coming from? Okay. Untitled, what are you doing there? Go away. It's not doing anything, it says. Yeah, it isn't doing anything, that's good news. Profile. Close network. Well, that's probably where we're going to start. Application. I always seem to do things in reverse. Never quite understood why. It's a habit, I suppose. So we definitely won't be doing the main application first, will we? C++ Pro. Yeah, we can just copy the whole thing. Actually, I will also put that space in at the beginning so I can do this properly. Thank you. It's easy to copy. There we go. That's everything there. Copy. And save by and pop them all in. Remove them all. And yep, remove them all. We need to redo this, don't we? So here we go. It's time to get our profile sorted out. I mean, it's not really difficult, is it? No, it's not. So header files, what do we want? We'll have source. I'm going to use forward slashes because I can. And the first header file is client application. .h. That's it. Space. And you might notice there's a lot less header files this time. Indeedy. And it's going to be source, network. In fact, it's going to look a bit more like a real program, isn't it? Oh dear. That's bad of me. Why shouldn't it be? .h. That's all there is. Okay. And under sources, we'll start at the top, which is client.cpp. And then it's source, client, application.cpp. And then it's source /network/network.cpp. That's it. There you go, that's a program written. That was quick. It's got nothing in it, but does it have to have anything in it? Yeah, that's it. Easy. So, there we go. All I'm going to do at this point is I'm going to put this in as a client setup. Yeah. Okay. This is episode, well, Explore 9, isn't it? I'll just put in part 1 of 9, #9, because I know what that means. And that's just client setup. There we go. Let's just pop that away, out of the way. Thank you. That's all done. Put that on the server. That didn't take long. Good. Right, let's go. Let's go. We can close C++ for a bit. Explore keeps open. Client source. Yeah, we'll go with the source. Where should we start? Let's start with network. We'll call this, well, it's a client, isn't it? So we're going to use namespace of client. That's pretty obvious. Let's have this in here. Thank you. So network CPP. It's standard setup. And that's just going to be network.h, please. And then it's going to be namespace. And it's going to be client. That'll do us for a namespace, I think. Copy, and we're off. We're off to the races here. What's going on, Blades? You're not normally this fast. Have you woken up or something? No. Just thought I'd give you something real. A real life application. This is it. It's a client. Lovely. Absolutely lovely. What shall we have in our client? Well, we can't really write our client until we've written our application. I really haven't got an application to write today, so we'll write it anyway. Because I'm really not that bothered. Yeah. Okay, networks. Clients, what will it need? Well, we've got it, so we're going to use it. We are going to include SDL2. I thought we had it. Nothing. Why not? Because we don't have our properties pointing in the right direction, do we? No, that hasn't changed. Just quick check on the profile. Dependencies are in the same place. Up 1 across 1. Down into dependencies. Okay. I know what it is, you know. Tasks.json. It's still on C++, so let's go over to client here. Whilst we're building and writing our client. Yep, that's okay. It's U modified. Launched. Ooh, yeah, lots of stuff here. Program, blah, blah, blah. That's a client. That's the client. Pretty printing. Oh, bless. Yeah, that's okay. There's only those two that we need to modify there. I haven't got something right. Let me just put Pragma once in some, and then I'll start trying to work it all out. Got a feeling I know why, but I don't like the feeling I've got. I know it's SDL.h, but why isn't it coming up? I've got GL. What the heck's in GL? Oh wow, I didn't know we got those free of charge with Windows. It's got SDDLH. Okay, it does want to play. As if I care. SDL.h. I can type instead. It can't find it. Can I open file? Okay. Okay. So what you're saying is that IntelliSense can't find it. So comma on my properties, and don't know why I have to put this in, but I'm going to try $, and it's workspace. Workspace folder / explore / dependencies. Should really have done it before, I suppose. Depend en C's / include. You should be able to find it now. You've got no excuse, thank you. That's all it wanted. It just wanted the properties updating. No idea why. Shouldn't need it with that star there. Hash include. And it's SDL, please, thank you. Now you're coming up. I love it. SDL, I love it when a system comes together. Net. There we go. What else should we have? We can have a vector. I like vectors. We know that I like vectors because it's an array that doesn't have a full stop on it. It's just an open-ended thing. String length we will need, of course, so that's hash include C string to take care of all our string bits. Do I need IO stream? Probably. I'll leave it alone for now. Hash defines. Now, this is where the interesting thing starts happening, because I'm going to start creating a bit more of our own language to use whilst we're developing this, because we're not just going to be writing this network.h for the client. We want to be able to use most of this code, or all of this code in fact, for the server. I mean, it's a class, that's all it is. I didn't call it client, I didn't call it server, I just called it network. So that's what it's going to deal with. So we'll have max users, and we'll set that at 15. Hash define. I know what's wrong, you know. I can't hear myself talk properly. Let me just try this. How's that? Oh, that's better. Oh yeah. Hash define, and it's not max users. It's going. We'll have a buffer. So buffer size, we'll have 4K, 4 kilobytes, 4096. That's good. You might notice that this isn't C++. What I'm doing is I'm writing this for the compiler. The compiler picks up all of the hash defines and hash includes. So all of these bits are compiler instructions. So if it sees max users, it's to replace that word with 15. If it sees buffer size, it's to replace that word with 4096. And we'll have a timeout as well. Probably won't use it, but just in case. So AFK time out. And we'll set that to 5,000, which is 5 seconds. There we go, that'll do. We've got a namespace. We're going to need a struct. I'm going to call it user data. Whoops. Because that's what it is. It's the user's data. We will have a TCP socket for whichever socket the user is using. Call that m_socket. And we'll have a uint32, please. I'm going to be more specific on this one. So it's an unsigned integer, but it's 32 bytes, and that's just for the m timeout, because that's the timer uses uints for some reason, and it uses a 32-bit system, so that's why I'm going to do that. That's for SDL, that for its ticks, its time system. We shall have, actually, first thing you should always do is put int ID. Really, shouldn't we? But it's going to be an MID. Really, we should have an ID. What else will we need? Bool is connected. There we go. Lovely, we've now got some variables and we're exploring, and we can see already that, hold on a minute, this is looking a bit familiar. It's got, bad one. Put semicolon at the end, it is C++ after all. I'm going to have my enum, which is my command. I'm going to put it out here in client. And that's going to be the same kind of thing as a struct, but it's just enums, as we know. What shall we have? We will have accept. Everything that goes in here has to be the same on the server as it is here. So we'll set that to start at 0. Why not? Then we'll have server. We've met these kind of commands before. So that's server full, wasn't it? Comma. And server shutdown we'll have as that one. We can have client connected. Don't know if we'll be using that one. We can pick and choose which commands we use. That's the beauty of this system. Client. What else can we have for the client? Well, if we have connected, we can have disconnect. Yeah, past tense. Okay. client data for transferring data, and client to client in case we want to speak to somebody. Yep, so that's it. So we can send client data to the server, or we can ask the server to pass a message on to another client. Yeah, that's the last two. So we know all about and why we're doing this now. We know what structs are. They're a form of public class, and we're calling it user data, so it's obvious what we're going to be using it for. But now what have we got? We have the class itself. Whoops. Class network. This is it. This is the biggie. Dun dun dun. Is it? Heck, it's not big at all. It's just like any other class, really, but we just haven't written any. So how can I say that? Right. Client has to connect to something, so let's have a char. We'll call it a server. And we'll make it 15, because that gives us 16 characters. Well, 16 bytes, or bits or bytes. So it's in base 16, that's alright there. We'll make it 127 dot Mr. dot 0 dot 0 dot 1. There we go. And that's that loop back that we used on Telnet in that episode a couple back. So that's that. We can have a port as well, so that's just an integer, isn't it? M_port. You know what I have forgotten? Yeah, I have. I've forgotten something. Import. Oh no. I just picked one at random, didn't I? I just put. Yeah, 2250. That's what I did. That's just information. I want a constructor for that. There we go. And the constructor is going to be... we'll go int ID, comma, TCP socket. We've got that good. And we'll call that socket. Then we have a timeout. Timeout. It's just a uint32 in it. Yeah, uint32. Yeah, we're allowed to do this. So timeout. And what have we forgotten? Is connected. Don't want that one, because that is obvious. We can't set that one at this. Well, we can, but okay, we're not gonna. We're gonna have bool is connected then. That's a member variable, isn't it? Dar. So comma bool is connected. Okay, I'm happy with that. Colon. And that is going to be MID equals ID, comma, and MSocket equals socket, comma, M_timeout is timeout. One above, please. Oh, God. Never mind. I'll type it. It's faster. And M is connected equals is connected. There we go. That's it, isn't it, really? Except for a couple of little braces. That looks right. Yeah. I like that. No, I'm happy now. I'm a lot happier because we've got a constructor. It means I can check if we connect, and if we connect, we can do the constructor for the user data. Fantastic, a plan coming together already. Where have you got there? Wow. I'm on form today, aren't I, eh? I'm well ahead of the game. Let's put a character in. What we're going to have, just an M buffer. Yeah, we better have one of those. Let's have a buffer. How big is it going to be? I don't know. Whatever you told me it is. We'll call it buffer size. There we go. So I don't need to worry about that. I do like my vectors, so we'll have one of them. And the vector is going to hold user data. Star. And that's just going to be all the clients, including us, as the 0th client, or the user. And the only other thing we're really going to need is the server itself, isn't it? So we'll use a socket set. We don't need to. We could just use a socket, quite honest with you. But socket set has some special properties, so we'll use that. I'll have that one, please. And we'll call it M server. How about that? Because we can. No, we can't. We've got one there. So that's going to be IP, isn't it? Yeah, that's its IP address, and that's the actual socket set. Okay. Yeah. Drop us back a bit and put public. Now comes the network. How are we going to do this? Well, it's a class, so we start off with the constructor, like we did here. And this constructor is going to be that. We're then going to have a destructor, which means really we should write the third part. There's a rule of 3 with classes. If you write a constructor that's fine. Just carry on your merry way. But if you put a destructor in, you should also put a copy in, so that you can copy your network to something else. But I don't want to be copying this, so I'm not really bothered. The base 5 functions that you get for a class are pre-written in the compiler and given to you as default. So really, if I was being pedantic, I would put equals default. So if you ever get a complaint from your compiler saying no default constructor found, that's how you make a default constructor. But hey ho, a destructor is tidal. That is a tidal mark. Mine is above the hash key on the British keyboard. On the American keyboard, I think it's up top left somewhere, where the apostrophe is, or something like that. It's in a weird place, I know that. Network. So that's the destructor, so we can destroy our class afterwards. Let's have some functionality. We've got data, so we've got our user data. That's the data that we're going to be holding on to. We might not, well, we're going to be accessing it here, aren't we? We could pass it in. Not really that fussy. Not at this point, anyway. Might be when I do the application. So what's the first thing we want to be able to do is send user data, our user data that is, to the server. So send user data. which will be a const char star data. That'll do. Yep. And that's going to be the next one, void send user to client. So send information from us to another client, and that will require the client ID. Here we go. Client ID and the const jar star data. Starting to look familiar now, is it? And the only other thing we're really going to need is receive. How do you spell receive? R-E-C-E-I-V-E. Receive data. Now, to make life easy, these functions don't actually do what they say. They're not actually going to send and receive. They are going to do the pre-processing for that send and receive. There's a reason for that, because it's a bit tricky, to say the least, because we're using SDL. And when it sends and receives, it might not do it all at once. So bits of your data may go and bits of data may come in. Ah, bless. Have I got any coffee or anything? Oh, yes, just a bit. So we're going to have two more functions. One called send, and that's just going to be const char star buffer, and void receive, R-E-C-E-R-V-E. I actually had to look up how to spell it because I'm useless. Doesn't really take anything. There we go. That's it. Lovely. That's your network. So that's the menu to the network. That's what it does. That's the functionality that we are going to give it. So we do that. We take everything from 47, don't we? Yeah, we'll take everything from 47 down to there. Copy that. There's not a lot really when you think about it. That's the header file done. There we go. And it puts it all over the place as usual. So I'll just do one at once. It's going to be network. Colon. I will take that for it. Copy. Take that off. And there we go. That's so... Sorry, my bad. Those are the declarations. And in here, we're going to write the definitions, the two braces. Sorry, my bad. I should have said that. And back. I'm not putting anything in them, notice, this time. There's a reason for it. Unless I mean it, I'm not going to put empty in anymore. I'm going to do everything properly and not mess about. Well, I might have a bit of fun with it and cock it all up. You never know. You know what I'm like? It wouldn't be a Blade show without it. Let's cock it all up, Blades. We're good at that. Oh dear. This is a problem, really. If you try and get sensible with programming, you're just wasting your time. Because the computer doesn't care. It's got no idea. I'll do that. Pop you in. Bring you back. Control V. I've already missed one, haven't I? 2. Told you I'd cock it up as soon as I started talking. Ah, bless. Never fails to amaze me how badly I can do things. But I'm good at it, and that I can say. If I'm good at one thing, it's cocking you up. There we go. So none of these are going to be empty, huh? Not that I can expect, anyway. Not a lot to fill in. But as usual, I'm going to go bottom to top. How's about that? So let's have a look at some functions. I want to explain these functions more than I wanted to explain anything else. So this is the prime candidate for what the heck are you doing, Blades? So I'll show you a different style of writing C++ at the same time. White space is ignored by the compiler, so anything that's in white space or behind these double dashes, or multiple dashes in this case, is ignored. So the compiler's going to ignore a heck of a lot of this, isn't it? Yeah, mostly. It's only after the definitions themselves. Right, so what we're going to do is I'm going to ask for an offset. Hopefully you know what an offset means. It means from position X, I want you to take X plus or minus whatever the offset is. Simple enough. I think we can do that. We did a while loop a while back, and this time we're going to do a do loop. Do loops are different. A while loop will go... don't do that to me. I hate it. Pet hate. While at the bottom. The while comes at the bottom. So a do loop has to go through the code once, at least once. A while loop may skip the code the first time if the condition isn't satisfied. So a while loop may not execute at all. A do loop has to execute at least once before it checks for the condition. Massive difference. So we know this is going to happen at least once. Our offset. What are you up to, mate? Well, you'll change. Why would I want it to change? Well, but what we're going to do, we're going to take our SDLnet, and I'm going to write it slightly differently this time with a lot of white space. TC, a lot of people do it this way. And I actually quite like it in this sort of place. What they do is, I put it all in capitals, haven't I? Do. R-E-C-V. Yes, I know it's that one, thank you. What they do, as soon as they open the brackets, they hit return. And you can see where it sets the cursor. And then they will type in whatever's next. M_clients, I think is the first bit. Yeah, clients. We are the user. And that means we have the socket. Comma, and it'll tell you what we need next. The data. Well, that will be mbuffer. We know what that is. But we might want an offset. So we'll plus the offset, just in case we need to. It's 0. So there we go. That's offset. Yep, comma. And then it needs length. Or max length, it says, not length. So buffer size, please. But we want to take off the offset, in case we've sent some already. And that's the end of that. So we can now close and... oh, it's already done it for us. So you put that there. And in the while loop, what we are going to do is check that the M buffer length M buffer, in other words, the end of the buffer strlen, thank you, and that's those kind of brackets. Alright, let's see what I've got there now. Still not right. I'm having trouble with this line. Come on, brain, there you go. So at the end of M buffer, or however long it is, at the end of it, we'll need to minus 1 off that because we want to look at the character at the end. If that is not equal to that \n we keep doing at the end of everything, then go back and continue receiving the data, because it hasn't finished yet. So I'm using that \n at the end of the data, at the end of whatever data we're sending, to check to see if we've finished receiving it or not. If we haven't, we keep on receiving. There we go. There is a question mark there. And what could it be? Expected a closing bracket. Well, you did, yeah. You did, sorry. My bad. I got my brackets all messed up in the middle. So there we go. I usually put space there as well to make it easier to read. So that's really how you receive using SDL, because we don't know how much we're going to receive at a time across the internet. We better just receive the first bit, check whether it's everything, because we put a marker at the end. And if it isn't, carry on receiving. If it is, well, we've got everything. M buffer is full of the data that we need. We can go back and sort out whatever we needed to sort out. You'll never guess what. Well, yeah, I know. The only difference between the two is that this needs 2 items. So we have int offset equals 0, and we also know the length of the string this time, so int, and it's going to be length, and it's data, isn't it, because we actually buffer. Okay, I'll call it buffer then. Grief. Why do I change the name on things? I don't know. Because I don't like buffer, because it's confusing. Because we do have a buffer, so it is data. It's really that's wrong, that I don't like. It should be data, really. And this is send, isn't it? Let's send data. There we go. Just clean it all up. Yeah, that's better, because the buffer is internal. str, I've done it again. I have that on the brain today, don't I? So we know the string length. We're doing well now. And because we don't know how much data, we're now going to do a while loop, because it's the other way round. It's the opposite to receive. So now we can do a while. and its offset is less than length. In other words, hasn't all been sent. Yep, looking good. So we have to send it at least once, because size is definitely going to be less than length, I hope, unless we've sent no data through to be sent, and we're just messing around. Size, yeah, okay, offset, and that is plus equals, isn't it? Like it was before. Yeah, and it's SDLNet underscore TCP underscore send, is it? Yep, there we go, that's the other one. Do that, do that. We need the socket again, which is inside the client. The user, who is client 0, has it. And it's clients plural, because we may have other clients to talk to. And there's the socket. Comma. Data is going to be data plus offset, in case it's in use. And then the last part, oh, that was bad of me, that's a comma. And the last part is length. That's right, yep. Minus offset. Just like it was before. And then it's semicolon. So you can see that them two are literally the same, but just reversing each other. The offset is used in the same way each time. That's the similarity to make everything work. The only difference is the buffer size and the length are used. It's different on those two parts as well. That's quite weird. But everything else is really the same for send and receive. Practically the same function, but ups on the head. The logic is on the head. Receive data. How shall we receive data? Should be fun. Let's have a while loop. So while we're receiving data, there. Let's have a look what we can put in here. We can put that SDLNet underscore check. What can we check? Sockets. Yeah, that'll do. That's the only thing we get. So let's check sockets. What do you need for the sockets? We need a socket set, which is going to be mserver. That is a socket set. It says it there. SDL socket set, mserver. Socket set. Yep, that's right. So, comma. A uint timeout. We've got one of them. 0. We don't want to hang around. We don't want to wait for anything to come in. So while it's greater than 0. In other words, if it's happening. And I'm not sure about this bit. Really not sure. Next line, and. Logical and. So this has to be true as well for it to work. SDLNet. Now remember, I haven't been able to test any of this. Although I know it works, it doesn't matter. I still haven't been able to. Socket ready, and the socket is ready. For socket ready, we need to know which socket. So we need the user socket, which is clients. 0. We need that socket there, please. That's it. That's all we need. Okay. 2 brackets to finish. Yeah, okay. There we go. So whilst those two are true, that there is a socket worth checking, and the socket is ready to be checked, doesn't sound right to me, because they both should. I've got a horrible feeling that SDL should really check that the socket is ready to be accessed. But I guess it's safer not to. Let's give ourselves a command. Why? Because we are using the command design. We'll pop it to -1. Because we know that that can't really exist as a command. So we're happy with that. That'll be an error. So all we do is receive. That's already been written for us. And it's EIC. That's why I had to check. Can you just excuse me one moment whilst I close the door? We've got a bit of background noise coming through. I don't know. If I can hear them through these headphones, then I think you can. Oh look, I've got all spellings now, because I was interrupted. So receiver's already been written for us, so we'll use it. And whatever we receive, we will have to do. So how are we going to do that? We can use S. Have we got these SS's? We haven't. Where are they? Where's SS scanf? Scalbina, there's SDL scan codes. I bet it is in IO. Always is, isn't it? Whenever I'm missing something, the only thing I'm usually missing is hash include, and I'm beginning to dislike that. Might write me own soon. There we go. Yep, we got it now. Clever, huh? Const char star. Well, that's M buffer. Remember, we've read it. We've received. We've received into M buffer. M buffer. Yep. So scan F. We're gonna have U. What are we scanning for? The very, very first number. So that will be the first, well, very, very first character or first integer. And could you please place that into the address at command? The address in memory of command. So we've extracted the command number from whatever that data was. Yep, so if, well, it can't be, can it? Because %d from M buffer must be at least null. Well, it must be something. Otherwise it would drop through to -1. Got you. Be careful. We've checked those just as a definite knowledge that we're receiving. Right, okay, I don't need the if statement. Good. What we do now is we invoke the command design pattern, which is what we're going to put in here. And we're going to be putting in something like command manager. If you remember back, And then it's going to be, we've received it. So it's going to be client. Yeah, client. Actually, no, I'm going to keep it as server command, so I don't have to change things. Server command coming in. It's come from the server. Then we can take the command and pass it in with m_buffer as the data. Now, why have I done it like that? Because we haven't written it. There you go, simple. If this is the only one I'll do here. Oh no, I'll do it outside as well, won't it? No, I'm not doing any of them here. Let's do the command design pattern properly. So all we need now is, because of the command design pattern, when we receive data, we can just pass it out through the command design pattern to the place that deals with whatever that command is. And if it says server shutdown, it'll close this program down. Something like that. Put semicolon at the end there. And that is how you receive data. Not a lot really, is it? Well, we've got one line to write. And I've already said what the line is. And I never put a semicolon at the end of that because it isn't written yet. That's what tells me that. That was complicated, wasn't it? Well, we have to put the design pattern in yet. That's a different story. Send user to client. So this is client-to-client communications. Maybe a chat server. Hint, hint. Dunno yet. I think that's what we might do first, because that's where you should start, really. If you're doing a server, the best way to check that a server is working is by making a very simple echo chat server, because it echoes back to you whatever you send, and it also will send it on to other clients, so they will see whatever the data is as well, and you can see something on screen every time. It's only a command line thing, and that's all it needs to be to start off with. And then we'll go and write the UI, or the graphical user interface or something. Okay, this is going to be a little bit simple now, because we now have sprintf, don't we, available to us, because we've got IOStream. I need a drink. So, IOStream, you've given me that sprintf, have you? Or C-string has. One of the two has. Which is good for us, because that means it's made our life very, very simple. This is where the power of the standard libraries takes over. Glass of black bubbly burpy liquid. Woohoo! Let's take the buffer, m_buffer. What we're going to do with it? We're going to take a format, or we're going to format it. Okay. Let's do... You might be getting used to this now, where I'm using %d as an int. For floats, you'd use f, and for strings, you use s. So %s, and then we need that \n because we need that for the receiver at the other end. Yeah. What do we need next? Oh, we run out of space to read. Okay. Well, I think we're going to need all that data, aren't we? So it will be command ::. What is this? Send user to client. So client to client is the one we want. we need to tell them which client ID, and what we're going to say to them. Well, data. That's it. And why is data a problem? It isn't. So now mbuffer is filled with the details that we want to send. Oh dear, is that it? Yep. Done. Next. Can you guess what this is going to be like now? This is going to be something like sprintf. This is just data, is it? Yeah. So it's going to be mbuffer, comma, no, I don't like this. I've got something wrong here. You know what I've forgotten? Yeah. If, open brackets, m_clients 0, if we, us, the user, is connected, then do these. If we're not connected, there's no point in doing it. 'Cause it ain't gonna go nowhere. So, if m_client 0, where's he put my cursor there? There we go. Is connected. There we go. Come on. So, buffer. What we need now is that. Oops. And it's going to be... We're only sending in the data, aren't we? So it's just going to be %s, isn't it? This is user data, isn't it? No, it's going to be %d, %s. Right, I think I've got it now. So, %d, %s, space, \n. Yeah. Comma. Command. Yes, you can see now where it's all going, can't you? Client data. So we're telling it what command or what's coming in, and then we just need the data, please. Okay, done. Yep, that's that. And then what do we need to do? Well, just send it. There we go. Hate to say this, but don't you think this command structure is making this very easy? Well, until we get to the destructor, it does. Gotta be careful here. Okay, the destructor for the network is close down, where we close absolutely everything. So, we need, because we might request a shutdown or to exit our program, we need that option. We're going to have to tell the server that we're disconnecting. So that's the first thing we do. So we ask printf m_buffer, comma, and it's just %d, isn't it? Space \n. go, and that's then just comma, only one thing, command, colon, client disconnected. There you go. So that's us telling the server that we are disconnected, or disconnecting, and the server will then respond by taking all our details off the server, which it's supposed to. Now we have to be careful, because at this point we have to take out or close down, release the resources that C++ doesn't automatically release. So here we go. This is fun. So it's the TCP close. It doesn't automatically close. We have to do that. This is why if you get a discon when you're playing a game, it sometimes takes a little bit to be able to reconnect into a game. It's because your socket's still open and the game is thinking that it's still connected, because nothing's closed and everything's out of sync and in a absolute mess. So it can take a few seconds for everything to be sorted out, for things to realise. 5 seconds is the timeout, so that's how long it takes for everybody to sort themselves out so you can reconnect. Yeah. That's why the timeouts are low. It's not because they get annoyed about people AFKing. It's because if people accidentally get knocked off the internet for whatever reason, many reasons for discons, they don't want people to have to wait too long. 5 seconds is a good rule of thumb, to be able to re-log back on. Yeah. And that's the reason why. Bet you never knew that. Bet you were always cursing those people for not letting you AFK all day. Well, the systems that I write will, because I don't care. SDL, net, I can break the rules. We better free stuff up. So what can we do? Free packets? No. Free that socket setup? Yes. That will cover mserver and get rid of that resource. And we've got a vector, haven't we? Yep, so if we've got a vector, we have to do this the usual. So count, come on, int count equals 0, and then it's count less than, what, mclients.size, yeah, dot size, semicolon, yeah, count plus plus. Sorry I'm having to rush this a little bit because I'm running out of time. Delete, I want to talk about this more. I might do that as a separate video though. Clients count, we obviously know how to do that. We've done it a million times before. So that's that bit. And the last part is for SDL to release everything. So it's SDL net, please, goes first. Quit. And SDL underscore quit. Alrighty. We're cooking. We're cooking on Saurus. Dark liquid, we burpy bubble, bubbles. The question is, how do we construct it? That's the biggest question going, isn't it? Is that what we do in our next episode? I think it is. I think we've nearly finished now. You probably can do the constructor yourself, but be warned, I might not do it the way you think. Interesting. Yes, I know. I have interesting methods. Yeah, I'm happy with that. That's all correct. I will obviously look over this and do a corrections for the next video, in case there are any, at the beginning of the video as usual. And I'll let you do your homework. So, homework. How do we construct the client? There we go. I'll give you a hint. You're going to need an IP address. If you can get the IP address, I'll let you off. I'll let you off all the homework if all you do is can get the IP address. Equals. Alright, if you can answer that one question, then the whole of the series has been worth it. I know I do this for beginners all the way through to advanced, so I'm trying to keep the programming side like middle of the ground, but understandable. I'm trying to keep it in English as much as possible, and not in computerese, which sometimes we fall into very easily. And that's it for today. I will catch you in the next episode when we complete our network and we are going to create the client application. Take care. Keep exploring. Don't forget the IP address. And have fun.